Okay, everybody, welcome back. In this video, we are going to continue exploring section 5.3 of AP Calculus, determining intervals on which a function is increasing and decreasing. We're going to look at a couple of more examples. First with an equation that's a little bit tougher than the polynomial that we did in example 1. And then we're going to look at a graph of the derivative and how we can utilize this information to find the intervals of increasing and decreasing there. All right, so in example 2, we're going to find all the critical points of g of t equals t times the cube root of t squared minus 4, and then give the intervals where the function's increasing and decreasing and justify our answers. So first things first, at the very least, I'm going to think about this function as t times the quantity t squared minus 4 to the 1/3 power. Even if I don't rewrite it as such, I should think about it as such when I'm taking the derivative here. So we're going to go ahead and start by taking the derivative of this function. We've got to utilize the product rule. So we've got g prime of t is equal to t times the derivative of the quantity t squared minus 4 to the 1/3, which is going to be 1/3 times t squared minus 4 to the negative 2/3. Times the derivative of the inside via the chain rule, so we multiply by a 2t, and then I've got the quantity t squared minus 4 to the 1/3 power, times the derivative of t, which is just 1. Okay, and if I simplify this and clean it up a little bit, this becomes 2t squared over 3 times the quantity t squared minus 4 to the 2/3 power, plus the quantity t squared minus 4 to the 1/3 power. And it's going to be easiest for me here to find my critical points if I combine this derivative into a single fraction. And I'm going to do that by finding a common denominator, the common denominator being 3 times the quantity t squared minus 4 to the 2/3. So the 2t squared stays the same, and then in order to get this over that denominator, I need to multiply this term by 3 times the quantity t squared minus 4 to the 2/3. When I do that, that gives me a plus 3 times the quantity t squared minus 4 to the 1st when I add my exponents. And so I'm going to go ahead and simplify this, and I end up with g prime of t is equal to 5t squared minus 12. all over 3 times the quantity t squared minus 4 to the 2/3. That's a really bad 3, sorry about that. A little better. All right, and now we're going to establish our sign chart. Draw a sign chart for the derivative g prime of t, and we need to find where the critical points are. So we're looking for where the derivative is 0 or undefined. Okay, so for 0, we set the numerator equal to 0 and solve this for t, and we get t equals plus or minus the square root of 12 over 5, whatever that is. I don't need to convert it to a decimal, I'm just going to leave it as such. That's where the derivative is equal to 0. And for the denominator, that's going to tell me where the function is, or where the derivative is undefined. And so that happens when t squared minus 4 is equal to 0. And so we get that t is equal to plus or minus 2. So f prime of x equals 0 for these values, and f prime of x is undefined for these values. So I'm going to put all those values on my sign chart. The square root of 12 over 5 is smaller than 2. So when I order these, I'm going to have negative 2, negative square root of 12 over 5, square root of 12 over 5, positive 2, and a whole lot of intervals to evaluate here. The derivative was 0 at these 2 points. The derivative was undefined at these 2 points. And now what I need to do is I need to take some values in each of these intervals and substitute them into this function right here to see whether it is positive or negative. Okay, and this gets a little tough for some of these. I'm going to start with this middle interval. 0 is in this middle interval, so I can substitute 0 in here for t. That gives me negative 12, so negative over, and negative 4 to the 2/3 is going to be a positive value. So I'm going to have a positive over a positive. Is that right? Oh, I'm sorry, I had a negative numerator. Negative over a positive, so that value is going to be negative on that interval. Let's see, I need a number between the square root of 12/5 and 2. Oh gosh. It's very close to 2. Let's just use 1.9 for instance. If I use 1.9, this value in here in the numerator is going to be negative, since 5 times 1.9 squared is a little smaller than 12. And this value in the denominator is going to be positive. Is that right? Did I get that right? Maybe I should use my calculator to help me here. And let me show you a little trick for developing sign charts when we have a derivative, when you have a calculator handy. I'm going to go ahead and show you this trick now. So suppose I'm trying to find a sign chart for my derivative. So I can go ahead and type my derivative directly in here. And this is something that I've found really handy over the years in helping me. I'm going to check my window. Yeah, that works fine. It should work fine. And if I go ahead and graph this derivative, I can use this to help me identify my sign chart and what's going on in my sign chart. This is the graph of the derivative, not the original function, the derivative. But we can see from this graph right here that down here between negative root 12 over 5 and positive root 12 over 5, the derivative is below the axis. This is going to tie in very nicely with our next example too. Is below the axis, which we already identified that the derivative was negative on that interval. If we look everywhere else in this graph, you can see the jump from the discontinuity there where the derivative is undefined. You can see it in these peaks right here. But the other thing you can see is that the derivative is positive in all of these other intervals because it's above the horizontal axis. So that's a quick way when I have a calculator to help me make a sign chart. Or I could just, slug through and pick values in the intervals and substitute them in there and figure out what's going on. Anyway, now that I have all of that information, we've got that g of t is increasing on the interval from negative infinity to negative 2, union negative 2 to negative root 12 over 5, union root 12 over 5 to 2, union 2 to infinity. And what happens here at all of these points where the derivative goes undefined, we've got well, let's look at the original function in a second and we'll see what actually tie that in for us. Because g prime of t is greater than 0 on those intervals, so it's increasing there. And g of t is decreasing on the interval from negative root 12 over 5 to root 12 over 5. All right, so what we're going to do, we'll take a look at the original function and kind of make sure that our behavior matches. So we'll take a look at that in a second. All right, so let's go ahead and we'll look at the graph of the original function at this point in time now, which I have here on Desmos. Y equals t times the quantity t squared minus 4 to the 1/3 power. Take a look at what you see. The function is increasing over here. It's increasing from negative infinity And at -2, we've got a vertical tangent for just an instant. It's increasing all the way to there, then the derivative's undefined, then it starts to increase again. We could probably even just write it in this case that it's increasing from -infinity to -√12/5. We could probably get away with that. But there's a look at what the original graph looks like based off of the sign chart information that we have. And we see that at -2 and at +2, since the derivative's undefined, we do have vertical tangents there. All right, I don't want to get bogged down in that too much. I do want to move on to our last example. Determine the intervals where f of x is increasing and decreasing based off of the graph of y prime equals f of x given below. Justify your answers. Well, in order for it to be increasing, the derivative has to be positive. Since this is a graph of the derivative is positive where the graph is above the x-axis. And the derivative is negative where the graph is below the x-axis. So I can just read directly from the graph, f of x is increasing on, and let's see, it's from -infinity up to -3, and from 1 to 3, because f prime is greater than 0 on those intervals. And it is decreasing on the interval from -3 to 1, union 3 to infinity, because f prime is less than 0 on those intervals. All right, not too bad when we have a graph like that of the derivative to help us identify. Okay, that's going to be it for this video and this lesson. Go ahead and get yourself a little bit of practice with this concept, and then we'll see you next time when we get into section 5.4, which is, oh my goodness, is that using the first derivative test? Using the first derivative test to determine local/relative extrema. That'll be our next lesson. All right, see you all next time. Have a great rest of your day, and enjoy yourself.